All right, so for this podcast, you really want to make sure you are paying attention because this is combining two topics. It's combining stoichiometry and it's also combining the ideal gas law. So you need to make sure that you don't have Facebook up, that you're not trying to do this in a hurry, that you're not doing this at 3 a.m. And if you are doing this at 3 a.m., well, go get a Red Bull or something because you really need to pay attention to this. So we already know how to convert to liters of a gas or moles of a gas when it's at STP. We know that 1 mole is equal to 22.4 liters. Well, when it's not at STP, we're going to have to use a combination of stoichiometry and the ideal gas law. All right, so when we're converting between moles and liters of a gas at STP, we know that 22.4 liters is equal to 1 mole. And we can use that, and that works. It's perfect. However, if it's not at STP, we're going to have to use the ideal gas law. So, you are going to have to use the ideal gas law and stoichiometry. This is how you know what to do first. If you are given liters of a gas, you're going to start with the ideal gas law. Then, if you are looking for liters of a gas, you're going to start with stoichiometry. So if you're given liters of a gas, you're going to start with the ideal gas law and then use stoichiometry. If you are looking for liters of a gas, you're going to start with stoichiometry and then use the ideal gas law. All right, so let's look, law, not lass. All right, so let's look at a problem. What volume of CO2 forms from 5.25 grams of calcium carbonate at 103 kilopascals and 25 degrees Celsius? Okay, so again, let's find out what we're looking for. And what do we have? Okay, so we have a pressure here. So we have pressure. We also have a temperature, which we will have to go back and convert. We were given grams of calcium carbonate. Calcium carbonate is a solid. So we cannot plug that information into the ideal gas law. So that information, we would not convert this to moles and then solve for volume that way. And if you go back and you look, it says, okay, if you're given liters of a gas, you start with the ideal gas law. If you're looking for liters of a gas, you're going to start with stoichiometry. So right here in the problem, it states what volume of CO2. You are looking for a gas. So you're going to start with stoichiometry. The problem that you have with this is that it gives you the amount of calcium carbonate, but calcium carbonate cannot go into the ideal gas law. It's not a gas. And also it's asking for the volume of CO2. So anytime that you are going from one substance to a different substance, stoichiometry is going to play some sort of role here. All right, so here's our equation. Calcium carbonate decomposes into calcium oxide and carbon dioxide. We know that we were given 5.25 grams of calcium carbonate. We are looking for liters. We're going to start with stoichiometry and figure out how many moles of CO2 I have. Once I have the number of moles, well, I have my pressure. I have temperature. If I had my number of moles of CO2, well, I have pressure, temperature, moles. I can solve for volume, and I know R, so I would have all the information I would need. So let's go ahead and figure out how many moles of CO2 I'm going to form with this many grams of calcium carbonate. So the first step, anytime that we are going from stoichiometry, we always need to go to moles of that substance. So we're going to go to moles of the stuff we know. And then we need to go to moles of the stuff we want, which is CO2. So I'm going to convert to moles. I use the molar mass in order to go from grams to moles. My grams cancel. Now I'm going to go to moles of CO2. So moles of CO2 will go on the top. Moles of calcium carbonate will go on the bottom. Anytime that you have moles to moles like this, you use the coefficients. And it's just 1 to 1 and everything here. So these numbers came from the coefficients. All right, so now I do the math. 5.25 divided by 109 is pretty much my arithmetic here. So I get 1.26 moles of carbon dioxide. So now I have my moles of carbon dioxide, I have my pressure, I have my temperature. Now I can use the ideal gas law. So now let's go to the next step. All right, so now let's figure out, okay, what information was I given? I was given a pressure of 103 kilopascals. I am trying to find the volume. I don't know what that is. I have the number of moles that I just solved for this. I just solved for this in the last part of the problem. All right, and I was also given a temperature of 25 degrees Celsius. It cannot be in Celsius though, so we're going to have to convert that to Kelvin by adding 273. So 25 plus 273 gives me 298. All right, and I was also given R. Now, normally we use the 0.0821 liters to atmospheres over moles to kelvins. Well, we're given kilopascals here, and we were also given a constant also in kilopascals, so we're going to use that one instead of having to do an extra conversion. So this just saves us a step. So this was in the last podcast. That number was also in there. So we will use this number because it has kilopascals in it. We were given kilopascals. It just saves us a step. If you really want it, you could use the other constant as long as you converted that one to atmospheres. All right, so now I have all the information that I need. So now I just plug and chug. So P is 103, volume is unknown. So I'm just plugging all the numbers that I know in. And now after I solve it, I'm going to get 1.26 liters of carbon dioxide. All right. All right, so let's do another problem. All right, so, how many grams of aluminum oxide are formed from 15 liters of oxygen at 97.3 kilopascals and 21 degrees Celsius? All right, so we're given an equation, that's good. And looking at the problem, I just want to look to see what information did they really give us. They said we have 15 liters of oxygen, and we have a pressure of 97.3 and a temperature of this. We're looking for grams of aluminum oxide. Well, aluminum oxide is not a gas. Okay, so since that's not a gas, we can't plug all this information into the ideal gas law and solve for moles, because you would be solving for moles of O2. You have to pay attention to the substance that you're given and the substance that you want. All right, so I am given liters. So since I'm given liters, I'm going to start with the ideal gas law and calculate how many moles of O2 I have. So if I plug all this information into the ideal gas law, since I'm working with oxygen here, I'm going to get something of oxygen. I would not get something of something else. I would not get a unit of something else. So let's see what information I was given. I was given a pressure of 97.3 kilopascals. The volume is 15 liters, and that's of O2. I don't know how many moles that is, so I have to figure that out. I was given a temperature of 21 degrees Celsius, which again I have to convert to Kelvin, and R. Because our unit right here is in kilopascals, I'm just going to use the other R. It saves us the conversion, so make it easy on myself. All right, so now all I need to do is just plug and chug. This is our equation. So I'm just going to plug everything that I know into the equation and solve for the unknown variable, which in this case is n. After I solve it, I'm going to get 0.597 moles of O2. So I have this many moles of oxygen. So now I need to do the second part because the problem is not asking for moles of oxygen. It's asking for grams of aluminum oxide. So now I need to do stoichiometry. All right, so I'm going from moles of O2, which is what I just found out. I just found that out. And I want to go to grams of aluminum oxide. So I'm already in moles of O2. I don't need to convert that to moles. It's already in moles. So now I just need to go to moles of the stuff I want, which is aluminum oxide. Then I can go to grams, because that's what it's asking for. It's asking for how many grams of aluminum oxide. All right, so moles of O2 to moles of aluminum oxide to grams of aluminum oxide. All right, so now whenever we do moles to moles, we use the coefficients. Moles of O2 will go on the bottom. Moles of aluminum oxide will go on the top. There are 2 moles of aluminum oxide for every 3 moles of oxygen. Those numbers come from the coefficients. All right, so now I'm going to go ahead, go to grams. So I use the molar mass. Whenever I go to grams for moles, I use the molar mass. All right, so now when I solve, I should have 0.597 times 2 divided by 3 times 101.96. Should give me 40.6 grams of aluminum oxide. All right, so the important thing in here is to really watch what you're doing. If you are solving for volume, so let's go back to that first slide. If you are solving for a volume, so if you're looking for volume right here, you're going to start with stoichiometry, then use the ideal gas law. If you're given a volume, you start with the ideal gas law and then use stoichiometry. All right, so we're going to do some practice problems in class. As long as you understand how to do stoichiometry and you understand the ideal gas law and you know this, you should be fine. All right, I'll see you in class.